Okay, so our second reaction in this chapter is going to be dehydration. So we've learned a reaction previously called the hydration of alkenes. So let's just remember what that is. We have our alkene, our double bond, and we have water. So our alkene and water with an acid catalyst, and that yields a alcohol. So we're going to add, let's draw in all these hydrogens. We're going to add an OH to one side of the double bond and a H on the other side. So an H and an OH. And remember our selectivity rules with that. Don't forget those. So the double bond then turns into two single bonds. So dehydration is the exact opposite of hydration. So we're going to take an alcohol, have an acid catalyst, and this time we're going to add heat to it. So that's how we're going to drive the reaction towards the alkene. And so we'll have our alcohol, our acid catalyst, and heat, and that yields our alkene and water as the products. So the exact opposite, we're going to have where these two, where the alcohol is, we're going to have a hydrogen on the carbon next to it be eliminated is what it's called. So both the OH and an H on a neighboring carbon are going to turn into water. So we then are left, if we remove the OH and one of the H's, we'll have the 4 hydrogens left, and that elimination results in a double bond plus H2O. Okay, so let's try a couple examples, or let me show you a couple examples of this before we do anything else. So we have our OH here on the carbon next to it. I'm going to remove a hydrogen. So our final answer for the dehydration of this molecule here, we're going to draw the same carbon chain, and then we eliminate water and replace it with a double bond. Let's draw that one more time, double bond. Okay, so the same thing on this next molecule, we have our alcohol, and then we eliminate one of the hydrogens next to it. So in this case, we could have gone the other way too. So it's the same molecule overall, but we could have eliminated hydrogen on the carbon going down instead of the one to the left. I'll draw that product for you guys. So we could either have done the one that I drew here, or we could have done the hydrogen here, and that leads to this product on the right. In the first example, we don't have that selectivity question because there's only one carbon connected, because this is a primary alcohol. We only have that one carbon connected. There's only one option of where the hydrogen can come from. So take a moment, practice these on your own. We have 2 problems here. I'm going to go ahead and do the answers, so you guys should pause the video, do it on your own, and then meet back up with me. So I'm going to draw the same carbon chain, and then I'm going to go ahead and circle what I'm going to eliminate. So here I see that I have an alcohol, and then I have my acid catalyst and heat. So I know that I'm going to do a dehydration reaction. So I'm going to draw in the hydrogen that I'm going to eliminate, just so that I'm very clear. So that I'm going to get rid of both the OH and the H. Those will turn into water, and then I'll be left with an alkene in between the 2 carbons that I eliminated those from. Again, this can go either way. So I drew the hydrogen on the right, but you could have gone to the left. That's fine too. So I drew in all of the carbons. I'm going to go ahead and draw in the chlorine as well, because that didn't change. That's not reacting. And then where the water was, I'm going to draw a double bond and then write plus H2O. Okay, let's do another one. So we have our alcohol again, acid catalyst, and heat. Oh, I guess I didn't mention this. Um, this symbol here, the triangle, called a delta. That means heat. I'm sorry, I didn't mention that. That is a symbol for heat, if you did not know that. So if I just put a delta, that means it's getting hot, or you have to add heat to the reaction. Okay, back to this problem though. So we have our carbon chain with an alcohol on it. So I'm going to circle that alcohol because I know based off my reagents, I'm going to do a dehydration reaction. I'm going to find the hydrogen that I'm going to eliminate. So we're going to have this hydrogen here. Again, we could go either way. And so I'm going to draw my carbon chain and then put my double bond where I eliminated the hydrogen and the hydroxyl group. Okay, so we'll do more practice with these dehydration reactions on our practice worksheets and on our homework, but that's the basics of it. I'll see you guys around.